Hi everyone. I just came across a flood inundation calculator. It's a plugin developed by Susan. I don't know her affiliation, but basically what this plugin does is that it helps you to estimate the number of times a place has been inundated or flooded um, within a year or within a specific time period. So this is really cool. Um, and I just want to make a short um, illustration of it. And basically, you can also first install it by, just putting in floodplain inundation calculator, and then you can install it yourself. I'm basically going to use the data that was attached to the publication. But also as an illustration, I will be doing just a quick demo on this location. Um, so there is only two things you need. That is your DEM, digital elevation model, and then your water level data. And I didn't find any water level data for this location yet. So I'm going to use also the data that was provided, and then you see how it works. It doesn't really work better because the data were not collected from this location, but we will see how it works. I also created this fake floodplain, but if you are lucky that your area has a repository on a floodplain shapefile, then you don't have to create this yourself. For the water level data, you can also, for example, this is a very nice website in Germany that provides water level data for each region. So if you are lucky to have this, your country provide such data sets, then it's also easy for you to get your own water level data. So let's see how it works. So there are also some rules that need to be followed. Your water level data must be, you must have a value for each day within the year. If you are collecting data for 30 years, then you have to have one value recorded for each year. Also, your DEM must be float 64-bit. If it's 32, it will not work. I don't know why, but that is one of the limitation of the plugin and how it should work. So we are going to use the translate tool. This raster is already in 32, so we will basically use floating 64 for it, and then you can see how it works. So you say DEM translate, and it exaggerates the extent a little bit, but that is fine. So the next thing we have to do is to bring in our water level data, and our water level data is in CSV. So I'm going to use the one that was published by the provider. And because it doesn't have XY, you need to say it is no geometry, and then you can add it here. What you want to do next is to just inspect to see if everything is okay. So what you have here is that the data has been collected for 30 years, And if you want to know how many years that have been collected, just divide by 365, and then just divide 365 by the total number of records, and then you will know how many years it is. So we will go to our plugin, and then we will use the DEM translate, and our daily water levels will be our water level CSV file, and then we just use a factor of 5, a factor of 1. I've experimented it a little bit within this area because the data wasn't collected from this area. You have to do a bit of an experimentation. So this, we can call it Inundation. And then we can put the results and see what happened. So we have values ranging from 0 to 65. So for each of these, we are able to see how many times a place has been flooded. So we can style this a little bit. It's a continuous raster, so we can change it to single band pseudo color. And sometimes I like to experiment. The min max value is still the same here, and then I'll do it to current raster actual value, and this I'll change to discrete. And then it's, if you check the documentation by the publisher, they advise to put it into quantile. But if you change it to quantile, you realize that it doesn't really make sense with the data. So this shows that for this part, almost the whole place gets inundated 365 times in a year, which doesn't really make a lot of sense. So we can choose either equal, interval, or continuous. So in the continuous, it gives you just a little bit of impression on how much more this area can get flooded. So you see that going into the developed area, they don't really get flooded, but if you inspect over here, it's possible to, it doesn't show, but it's possible to know how many times the place gets flooded. But so this is what you can do if you have your water level data. I'm going to use the data set that was provided by the publisher, and then you can get a bit more better view of the two. So I will add the raster. So this one we will use the raster of the area. We can also use, the data set is already on. So we can go to the area. So this is the area, and it's a very high resolution DM. I think it's 0.1 meter or so. So next, we also have our water level data. So we will just go straight to using the tool, and you want to use your DEM, and this you want to use your water level data. There is a way to compute water level for your region by simply subtracting your elevation from your water depth. For example, if you have some boreholes in the area, or you have a way of estimating, then that would be a very good way of calculating it if you don't find it. We will change the correction factor to 5, and then we will run it. Okay, I didn't do something correctly. We have to save it. inundation tool, and then we did it again. It didn't work out. Let's try again. WLD, yeah, and then I think this should work fine. So you get a message that says congratulations. And then we can inspect, we can perform the visualization also here. We're changing it to single band with cumulative. If you do it in cumulative, then you are going to get a wrong value. So I'll basically use the min max. We'll change it to the current canvas. And then we will change it also to the discrete, and then we can make it as for these values. If you use the Panther, it works quite well, and then we will just leave it at 5 classes. Then we need to also use this. We'll change it to single band. I didn't change that, so that was a bit of a challenge. And then I think we can just remove this, and then we'll be able to see the results here. We can change the color ramp to maybe turbo. This is also not really the best. So basically where you have 76, this location, it just show you that this place can inundate more than 76 times in a year. If you go here, this is also very low, 18 times, and then here 102 times. If you go close to the river, then you see the high inundation times recorded. So yeah, this is really cool, a cool to estimate. It's not that there are a lot of restrictions on it, which I will attach the documentation in the description.